Hi, this is Mrs. Lee, here to help you with Activity 1, Problem 2. So we're going to start out with a couple of problems first, before you can maybe solve that problem by yourself. So the first one is going to be 5x cubed times 6x cubed. And if you guys remember anything about exponents from previous years, or this year maybe, we know that the cube is just for this x. So this literally means 5 times x times x times x. So you see this 3 times, and that's why we have it to the third power. People didn't want to write it 3 times, so that's why we shortened it up and said x to the third power to mean x times x times x. Now we're going to take this and we're going to multiply it with this guy right here. So 6x to the fourth power. So 6 and then x to the fourth means that there's just going to be, we're going to multiply x 4 times. So x times x times x times x. So that's 4. Thankfully it's not 40, or else we'll be here all day. I'll be writing 40 x's on here. So from here, what you're going to do is you're going to just, so remember, if you multiply, it doesn't matter what order you multiply in, as long as you just multiply them. So I'm going to take the 5 and the 6. Since everything is multiplying, I'm just going to multiply 5 and 6, which is going to be 30. And how many x's am I multiplying now? There's 3 here and there's 4 there, so actually it's x to the 7th power. And so if you guys see a pattern, if you want to get from this problem to just this answer right here, you don't always have to write these out like this. This is expanded form. You don't need to do that. You can just, let's see, you can just multiply these coefficients. 5 times 6, there's 30. And then if you look at these exponents, yep, say it, you're just going to add them. Okay, so because this is telling us that there are 3 x's to multiply, and these are 4 x's to multiply. So this is repeated addition, which is multiplications. So that's why it's going to be x to the 7th power. So there's that one. Now we're going to go to this second problem. If you look at the second problem, this is going to be, let's see, 3/4 x squared times 1/2 x to the 5th power. I looked ahead to the next problem, and there seemed to be some fractions on there, so I was like, why not do some fractions? Yay, happy days. So we're going to, sorry, I'm having issues with the recording. So we're going to, I'm just going to expand, I'm just going to multiply these just like, we're going to do the shortcut way. Instead of having to expand it all like this right here, we're just going to multiply the fractions. If you remember about fractions, if you're multiplying them, the good thing about multiplying them is that you do not have to find common denominators. That would only be for adding or subtracting, but not for multiplying and dividing. So we're going to multiply the 3 times the 1, which is just going to be 3, over 4 times the 2, which is 8. Okay, so 3/4 times 1/2 is going to be 3/8. And then we're going to be multiplying the x's, so x. Remember, don't put this x on the bottom. If you put the x on the bottom, it's a whole different kind of problem. That's a different lesson here altogether, so we're not going to do that. So there's x, and remember there are 2 x's here, x times x, and here these are 5 x's, so altogether we're multiplying 7 x's. Oh, same as above. That was just coincidental. So there's that. Okay, and then we're going to go to the next part right here, next problem, which is going to look like this. So now we have square roots. Okay, so if you remember, if you watched the video from the first video, Miss Young was talking about changing these to look like exponential form. This right now is a radical form because it has a radical. This is called a radical, like totally radical dude. And then this one is exponential form because this has exponents. Although this has exponents too, but ultimately we're looking for these radicals. So we're going to just rewrite this first to make it look more like these problems on the left, like 1 and 2, and then we're going to move on. So we're going to go 5. Now, if you remember our exponent, if there's no exponent on here, there's just a 1. And our radical, Miss Young had said, if there's no number here, the number, which we call the index number, is a 2. So that's going to be over 2. Think of like square root. So the square is in the root, which is in the bottom. Okay. And then same thing with this one. So x to the third power. This one has a power. So we're going to write that down. And then remember, this 2 is the root. So roots, where do roots go? On the bottom, under the ground. So here's the ground. It's under the ground. Okay, and we're going to do the same thing for the second one right here. Oh, look, it looks exactly the same. So we're going to go 5, and then remember the exponent is 1. So 1 over 2, which is our root again, times 3 over 2. Okay, so now that we have that, what we're going to do is we're going to do the same thing as what we did here, right? But the problem is that we have these exponents here, so we're going to have to treat these like how we did the x's. So what we're going to do is we're going to go 5, and then remember we're going to be adding the adding the exponents. So it's going to be 1/2 plus 1/2. I'm just going to rewrite it. Normally I would not do this, but we're just going to do this right now since this is just practice. 1/2 plus 1/2 because we're adding the exponents, and same thing with the x's. That's going to be 3 over 2 plus 3 over 2. If you are like, what in the world is going on, Miss Lee? You can just look over back here at number 1. Remember, we added the 3 plus the 4 to get 7, right? So it was 3 x's over here and 4 x's over here to give us a total of 7 x's. We were adding the exponents. So we're going to do the same thing here. It's kind of hard to imagine 3/2 of an x, 3/2 of another x. That's just weird. But we know the same rule applies. So we're just going to do that. Okay, don't make me write down 3/2 x. We're not doing that. So from here, I'm just going to simplify it some more. 1/2 plus 1/2. If you eat half an apple plus another half an apple, you actually ate the whole apple. So that's 1 whole apple. And then this is going to be x to the 3. Remember, these have common denominators, happy days. So it's going to be 3 plus 3, which is going to be 6 halves. Okay, and I'm just going to simplify this down some more. And I'm just going to go 5. I'm not going to write the 1 because we already know that that's a thing. We don't need to worry about that. Because we already know that that is an invisible 1 there, and then it's going to be x. If I go 6 over 2, well, I know that 6 divided by 2. Remember, that's fraction bar is the same thing as divide. 6 divided by 2 is just 3, so I'm like, oh, 3. Boom. Okay? And if you notice right here, if you look at the square roots of the square roots, 2 square roots together, hint for next year in geometry, they do cancel out. So you end up getting whatever's inside. But that just happened just for this time. That doesn't always happen. You would use the same process for any kind of radical. All right. On to the next one. Yes. So number 4, what I actually did was I did some multiple choice just for you guys, just because so it kind of looks like your number 2. So here we go. Now we're going to just put it all together what we've learned. We are going to first, like how we did for number 3, we're going to rewrite it in exponential form. Because our answers, I look at my answers, I'm like, oh, they're in exponential form, so I probably need to get rid of these radicals. So let's rewrite them so to make it look different. Okay, so this first one right here, I'm going to just write over here. So this is going to be 3. Remember, my exponent is, there's no exponent there, so that means it's invisible. 1. Boom. And remember my roots, this is the 5th root. So this is going to be to the over 5. And then this is going to be x. My power is 4. And my root is 5. Roots go on the bottom. And then that's going to be multiplied by over here. So it's going to be 3 to the, there's no exponent again, so that means it's a 1 over 5. And then x, my power is 2 over 5. So again, the roots are both 5 in both cases. They don't always have to be the same, but these are. So if you look right here, we're going to do these exact same way as we did the one for number 3, and number 2, and number 1. So I noticed that my 3's have an exponent, so I can't just multiply 3 times 3. It doesn't work like that. So I have to treat these like the variables. So I'm going to leave this as 3. And remember, I'm adding the exponents, so I'm just going to write it out. 1/5 plus 1/5. Good thing they have the same bases. Happy days. Times x, and this is going to be, remember, we add the exponents. 4/5 plus 2/5. And remember, you can only add the exponents because we're actually multiplying all the bases. And if you remember from Miss Young's video, the big numbers right here, the 3x's are the 3x and the 3x are all bases. And they are all multiplying because you see there's no pluses, no minuses, no like divide, just these multiplying. Okay, so now this is 3 and then 1/2 plus, 1/5 plus 1/5 is 2/5. And then times x, and then 4/5 plus 2/5 is 6/5. So I like to work it out first, and then I like to check the answers because it makes a little bit more sense to me. So I look at this, I'm like, oh, 3 and 2/5. Yep, that's exactly like mine right here. But then I notice, oh, this is an 8 and that's a 6. They probably multiplied instead of added, so that's not good. So nope, not this guy. And then let's look at this one, 3 to the 1/5. Okay, yeah, I got 3 and I have 2/5, so that's definitely not it. And then this is 9 to the, so nothing looks like this. So hopefully it's one of these two. And if you, so I'm going to go back to what I know, and I'm going to need to rewrite this a little bit more. So if I remember, it looks like they both have x to the 6/5. So I know, well, it's got to be one of these two. And then I look at this 3, I know that 3 squared is 3 times 3, because that square means I'm multiplying 3 twice. So I could actually write this as 9 to the 1/5, because all I have left is 1/5. X to the 6/5. So this is an equivalent answer. And I look, oh look, yay, happy days, let's see. Okay, and I know it couldn't be this one because the exponent is exactly the same as the one I have, but the base is different, so that cannot be right. So this would definitely not be it anyways. So there it is. That is going to be the answer. So hopefully those will help you. If you want to listen to this video again, stop, pause, maybe do it yourself, and then look at the answer again. That might be helpful. So hopefully this works out for you. Go and do problem number 2. Have a good one. Bye-bye.